Hi all, in this video I'm going to go over another example of applying transformations to a basic function. So let's just jump right in. I would like to try and use transformations to sketch a graph of f of x equals -3 times the square root of 2x plus 2. Okay, so very first step when you're trying to graph something using transformations is you have to identify the basic function that you're transforming. So what is my basic shape that I'll be stretching or shifting or flipping or compressing? In this case, the transformations will always be fairly simple stuff, multiplying or dividing by a number, adding or subtracting a number. So the one thing I see that doesn't appear to be a transformation is this square root, which means I would like to start with y equals the square root of x. So the basic square root function is what I'm going to transform. Looks something like this. And I'm going to pick a few points to follow. I would always follow 0, 0. That's a really key point on the square root graph. We're going to want to know where our final graph dead ends. So using that as a starting point is a great plan. I'm also going to follow 1, 1 and 4, 2. You can choose whatever points you want. I think I will use 3 for this one. If you have asymptotes or something, I don't think you always have to use 3, but this seems like a decent plan here to get some variety. So I need to take this graph and apply all the transformations that I see up above. So let's go ahead and start picking out the transformations. The -3 out in front is actually 2 transformations. Remember, when you're multiplying by a negative number, what that means is that you have a flip and also some sort of stretch or compression. So the negative out in front looks to me like I'm going to get a vertical flip or a flip over the x-axis. So I'm going to flip the graph upside down. With the square root function, it's actually kind of nice. Even though you don't have parentheses, the square root basically takes the place of the parentheses. So if your basic function is b of x equals square root of x, in order to get something under the square root, you have to input it into the function. If you want something to end up outside of the square root, you have to apply it to the output of your function. You can also think of this as an order of operations thing. So once you've identified that your function is a square root function, if you think about plugging a number in for x, anything that you would do to that number before taking the square root affects x's, and anything that you would do after taking the square root affects y's. And this works for other functions as well. This isn't just a square root thing. So once you've spotted your function, if order of operations tells you you would do that to x before the function happens, then it's x's. If you do it after the function happens, then it's y's. So here, if I input in x, I would double it and add 2, and then I would square root. So those are both x's. Once I square root, I would multiply by -3, so that's all affecting y. Okay, so vertical flip, flip over to x-axis, and also vertical stretch. Okay, to get the stuff under the square root, I have to be a little bit careful. It's looking like I have a horizontal compression. Remember, x stuff is always backwards. So even though it looks like double your x, what you actually have to do is cut your x in half in order to get the same y value you would have from the original function. The +2 appears to be a shift left 2, but this is where I have to be careful. If I have a horizontal shift and horizontal compression, I'm going to need to make sure that I factor, or I will get my shift wrong. So now I can see that it was, like I said, horizontal compression. So the factoring isn't going to change what we said about the 2 attached to the x by multiplication. That's exactly what it looked like it was going to be by 1/2, or maybe exactly the opposite of what it looked like it was going to be because it's x's. But the shift does change, right? This was a +2, now it's a +1, and the +1 is the correct one. So I have a shift left 1. You get to decide how few or many steps you are going to do. I would say the only thing to be careful about here is you should do the shifting last so that you don't mess anything up. I think I'm going to go ahead and do the vertical flip first, and then I'm going to do the the vertical stretch and the horizontal compression together. You can combine or not combine. However works for you is fine with me. So I'm going to break this up into a few steps, but I'm not going to do every single one separately. Okay, so first thing, flip over the x-axis. So this entire square root function is going to get flipped upside down. I'm kind of going out of order here, but I think that's pretty safe with a flip. To follow point by point and make sure I'm on track, I'm flipping over the x-axis. So 0, 0 won't move. Changing the sign of all my y's is another way to look at it. 1, 1 will end up at 1, negative 1. 4, 2 will end up at 4, negative 2. Okay, so this is just the flip. Next, I want to do the, what are they? Vertical stretch. I don't think I finished that one. By 3, and horizontal compression by 1/2. So I'm going to triple my y values and half my x values. So this will still be upside down, but it's getting taller and skinnier. So it's definitely going to look a lot steeper. I'm going to give myself a little more room down at the bottom. Maybe I'll need it. Okay, so 0, 0. If I apply vertical stretch to 0, 0, that's away from the x-axis, so it actually doesn't move. If I then apply a horizontal compression toward the y-axis, it still doesn't move. So right now, I've gone through 3 transformations, and 0, 0 has not been moved by any of them. 1, negative 1, if I do vertical stretch, I'm tripling my y's and I'll land at 1, negative 3. If I do horizontal compression, I'm cutting my x in half, so I'll end up at 1/2, negative 3. 1, 2, 3. Okay, so 1/2, negative 3. And then last point that I have, 4, negative 2. If I do vertical stretch by 3, I'm going to end up at 4, negative 6. If I then do horizontal compression by 1/2, I'll end up at 2, negative 6. 2, 3. Okay, so this has, again, both transformations are making this look a lot steeper. Okay. So that's roughly what we have going on right now. And then the last transformation, and again, if you're comfortable, you can combine these. The last transformation is to shift left 1. So the entire graph is going to look very much like what it already does look like, but it's going to be moved. Oh, I'm trying to move the wrong way. It's going to be moved to the left 1 unit. So I'm going to give myself a little bit more room. So this is 4. 0, 0. If I shift left 1, we'll end up at negative 1, 0. 1/2, negative 3. Shifted left 1 will be negative 1/2, negative 3. 2, negative 6. Shift left 1 will be at 1, negative 6. So very similar. This steep looking square root shape shifted to the left 1, and that is my final graph. All right, thank you for watching.